Okay, in this problem, I just wanted to do an example. It's a little different than the frequency table when we actually have the data values within the frequency table. This is giving us some probabilities. So what we want to do here is write down the probabilities this is giving us. Okay, so it says approximately 2% of women ages 40 to 50 have breast cancer. A woman has an 86% chance of positive test result from a mammogram given she has breast cancer, which is a true positive, and a woman has a 6% chance of a positive test from a mammogram given she does not have breast cancer, which is a false positive. So this wants us to complete the table and give our answers in 4 decimal places. So let's write down the information we know. Okay, it's telling us 2% of women have breast cancer. Okay, so that's telling us the probability that they have breast cancer equals 0.02, right? Okay, so when we look at the contingency table, we look at this row total is going to be 0.02. Okay, so the probability that they don't have breast cancer is going to be the complement of that. We can use a little hash mark here or a little C. Okay, and the complement of that is always 1 minus that probability, right? So this is going to be 0.98 because we do 1 minus 0.02. Are you with me? Okay. So now if we add those together, our total should always be 1 here when it's just in the probabilities. Okay, let's look at the other information that's given to us here. Whoops, sorry about that. A woman has an 86% chance of a positive test from a mammogram given she has breast cancer. So that's telling us the probability that she has a positive test result given, remember we use the straight line here, that she has breast cancer is 0.86. Okay. What else does it give us here? That's the true positive. She has a 6%, oops, forgot my highlighter, chance of a positive given she does not have breast cancer. Okay, so that's the probability that she has a positive test result given she does not. I'm going to write that as the complement of B is 0.06. Okay, so now to get the probabilities inside the table, those are the joint probabilities. So we're looking for the probability that the woman has breast cancer and a positive test result right here, right? So we are looking for the probability that she has breast cancer and a positive test result. Now, in some of the videos that go with the homework problems, it actually shows this as probably intersect P. That means the same thing as and. Okay? So if you remember from the multiplication rule, this is the probability that she has breast cancer times. Remember, if they're independent, we just multiply times probability that she had a positive test result. Since we have these conditionals over here, they're not independent, so it's the probability at positive test result given she has breast cancer. Okay? So using that multiplication rule, the probability that she has breast cancer is 0.02 times the probability positive test result given she has breast cancer is 0.86. So when we multiply that, 0.02 times 0.86, we will get 0.0172. Okay? So in our table here, we have 0.0172. Make sense? Okay. Now let's do our other one right below it, which is the probability she does not have breast cancer, right? And a positive test result. So this would be the probability that she does not have breast cancer times the probability of a positive test result given she does not have breast cancer using our multiplication rule. So we have 0.98, right, from here, times 0.06. So when we do 0.98 times 0.06, we get 0.0588. So that's this right here, 0.0588. Okay, now the rest of the table we can get from addition or subtraction, because remember, our row totals, these two added together will equal the row total. Okay, same thing with the column totals. Okay, these two added together will equal our total down here. So if we do 0.0172 plus 0.0588, we will get 0.076. Okay? Now, when we do our row totals, because we know adding these two together will equal our 0.02, we can just subtract 0.02 minus 0.0172, and we get 0.0028. Okay, and we can do the same thing here. We do 0.98 minus 0.0588. 0.98 minus 0.0588. And we get 0.9212. And then we add those two together, 0.0028 plus 0.9212, and we get 0.924. And of course, when we add these two together, we should also get our 1 here. Make sense? Let me know if you have any questions.